If you found the latest James Webb Space Telescope images impressive, prepare yourself. The ones you're about to see will shift your entire view of the cosmos. A new space telescope has begun quietly transmitting images so sharp, music so expansive, and so revealing that scientists are freely admitting they weren't ready for what appeared. The Euclid Space Telescope has now released music, its first light images. And these don't merely display stunning galaxies. They uncover structures we scarcely comprehend. Music, patterns formed by unseen forces, in a universe far more intricate and disquieting than we had anticipated. Tonight, I'll guide you through exactly what Euclid has captured, explain why astronomers describe these images as revolutionary, and reveal why some find them genuinely unsettling once you grasp their meaning. Stick around until the end. This marks only the start of what Euclid will soon disclose. Euclid isn't your typical space telescope. It was never meant to zero in music on one nebula or magnify a single breathtaking galaxy. Its true purpose runs far more ambitious, and music far more unnerving. Launched by the European Space Agency in July 2023 and stationed 1.5 million kilometers away at Lagrange Point 2, Euclid exists to chart music, the universe, at a scale never before attempted. Its ultra-wide field of view lets it seize massive swaths, music, of sky in one go, all while preserving extraordinary detail. That capability allows Euclid to resolve individual galaxies sharply and simultaneously show how millions link together into immense cosmic frameworks. What makes this especially troubling is that Euclid isn't simply charting visible light. It's mapping the reach of dark, music, matter through faint distortions in galaxy shapes produced by gravitational lensing. Put another way, Euclid is laying bare the skeleton of the universe, a framework molded music by something invisible and only partially understood. When Euclid transmitted music, its initial mosaic of the southern sky, the scientific community stood stunned by the sheer magnitude on display. In a brief music observing session, the telescope gathered 260 images spanning an area 500 times larger than the full moon. Stitched together, music, those frames exposed millions of stars and galaxies. Yet this covers roughly just 1% of the complete map Euclid is music projected to produce. That single fact alone unsettles. What appears before you isn't music, a complete view, but a mere sliver of something vastly larger. Researchers can zoom seamlessly from the grandest cosmic music architectures down to single galaxies without any loss of sharpness, exposing how matter arranges itself across music enormous spans. This mosaic isn't merely a picture. It's an early glimpse of the most extensive and precise 3D map of the universe humanity has ever pursued. And right away it forces uncomfortable questions about how little of the cosmos we've actually examined. Among the most troubling discoveries in Euclid's opening images, music emerges from the Perseus cluster, situated some 240 million light-years distant. That one frame displays over 1,000 catalog galaxies, plus more than 100,000 faint background music galaxies farther out. But the genuine jolt arrived when scientists examined it more closely. Euclid music uncovered over 630 dwarf galaxies previously undetected within the cluster, objects so dim they had evaded every earlier survey. This discovery carries weight because dwarf galaxies respond with extreme sensitivity to dark matter's gravitational pull. Their forms, locations, and distortions serve as markers. Music pinpointing where dark matter clusters most densely. The presence of so many that remained hidden until Euclid suggests dark matter's grip may prove far more elaborate than earlier theories allowed. The universe doesn't merely hold dark matter. It seems constructed around it. Euclid's images are reshaping not only our grasp of large-scale architecture, but also exposing turmoil at smaller levels. In galaxies such as NGC, music 6822, Euclid exposed low metallicity stars mirroring conditions from the early universe, providing a window into galaxy formation billions of years ago. Within globular clusters like NGC 6397, Euclid resolved faint outer stars previously overwhelmed by brighter companions, yielding fresh insights into the Milky Way's past. And in areas like the Horsehead Nebula, Euclid's keen sensitivity detected signs of free-floating planets and Jupiter-mass bodies wandering starless, hinting that rogue planets could vastly outnumber our previous estimates. Together, these views sketch music, a cosmos neither serene nor orderly, but restless, densely packed, and perpetually reshaped by music, forces both seen and unseen. As teams started piecing together additional Euclid music data, one inescapable and disturbing pattern surfaced. Galaxies do not drift music randomly. They align along immense filaments, gigantic cosmic strands spanning hundreds of millions of light years and crossing music at dense nodes where clusters take shape. Euclid's images render this web starkly visible. It resembles less a tranquil universe and more an enormous neural network, with matter channeled along invisible routes carved almost entirely by dark matter. Those filaments have moved beyond theory. Their effects show plainly in the way galaxies warp, elongate, and music orient themselves. The music truly frightening element isn't their presence, but their immensity. This cosmic web governs the universe, and every galaxy, every cluster, every void remains caught inside it, directed by forces we music still cannot directly sense or measure. One of Euclid's most disquieting strengths lies in its precision at detecting gravitational lensing. By picking up minute shape distortions in far-off, music galaxies, Euclid effectively unmasks dark matter's locations. Those distortions, music, stay subtle, nearly invisible without Euclid's clarity, but when charted across millions of galaxies, a stark picture forms. Enormous pockets, music, of dark matter curve space-time, twisting light from objects farther behind. What makes this alarming is the complete invisibility of these colossal structures. They emit music, no light, reflect none, yet their mass dwarfs everything visible. Euclid presents a universe, music, ruled by a dominant form of matter we cannot touch, one that quietly steers the paths and destinies of whole galaxies. Euclid's penetration, music, into deep-time layers on further unease. Certain galaxies in its initial images sit more than 10 billion light-years distant, so their light set out when the universe remained youthful. Capturing these ancient systems beside nearer ones in the same frame lets scientists, music, follow cosmic structures' development across nearly the entire history of the universe. The evidence points to large-scale, music, architecture assembling earlier and more rapidly than models forecast. Galaxies group quicker. Dark matter clumps sooner. The cosmos may have matured much faster than predicted, compelling a rethink of cosmic evolution and whether our grasp of gravity remains incomplete. Perhaps the single most disquieting truth is this. Everything described so far, music, stems from about 1% of Euclid's intended survey. 99% of music, the map still lies ahead. Over the coming 5.5 years, Euclid will keep sweeping the sky, closing gaps, refining details, music, and uncovering patterns we haven't even learned to recognize. If the universe already appears this way at 1% clarity, the finished view could prove overwhelming. Euclid isn't simply gathering pictures. It's constructing a dataset so immense and precise it may demand basic shifts. Music, in cosmology, from the essence of dark matter and dark energy to the rules driving universal expansion. Another deeply unsettling insight from Euclid's data concerns not where galaxies reside, but where they vanish. Immense swaths of space look nearly vacant. Enormous cosmic, music, voids extending hundreds of millions of light years. Yet Euclid demonstrates these voids aren't truly barren. They hold shape, boundaries, and definition from the same unseen music forces that sculpt galaxy clusters. The way galaxies arrange around these voids implies dark energy may actively repel matter, hastening space's expansion. In Euclid's music frames, the voids appear less like absences and more like stress zones where the universe stretches thinner. The alarming suggestion is that cosmic large-scale structure isn't merely music drifting apart passively. It's being deliberately reconfigured. Euclid was engineered not music solely to chart dark matter, but to pursue dark energy, the enigmatic driver thought to fuel accelerated cosmic expansion. Through precise positions and redshifts of billions of galaxies, Euclid tracks how expansion has varied over time. Initial review of music. Its earliest data shows slight but steady departures from standard models. Those deviations hint that dark energy might not remain constant as long believed, but could be changing. Should that hold, our picture of cosmic history would shift fundamentally. The force, music, deciding the universe's fate may prove more fluid, more intricate, and far less predictable than assumed. With Euclid's datasets expanding, scientists confront a novel music difficulty. The volume of information overwhelms. We're past thousands or millions of objects, now billions of galaxies mapped in full 3 dimensions. Human instinct falters at such magnitude. Universe-defining patterns grow too vast for direct intuition. They demand sophisticated algorithms, music, and artificial intelligence. In effect, Euclid compels reliance on machines to interpret what machines have recorded. That creates an odd loop where our cosmic knowledge increasingly hinges on systems processing data outside ordinary human grasp. The real terror lies not in the data, but in how much reality might lie beyond intuitive human understanding. Perhaps the deepest unease stirred by Euclid's early music images concerns physics' very foundations. Dark matter, dark energy, gravitational lensing, accelerated expansion. These phenomena rule the cosmos. Yet the theories explaining them bristle with gaps and placeholders. Euclid's sharpness lays bare how much of our cosmic framework rests on unknowns. We map effects with stunning accuracy, yet the true character of the driving forces eludes us. Euclid doesn't merely unveil the universe. It exposes the boundaries of our comprehension, presenting a cosmos where most of what governs is invisible, unexplained, and known solely through its sway over everything else. At first look, Euclid's images stun with beauty. Galaxies, music, shine, nebulae spiral, star clusters gleam in near-artistic harmony. But the more scientists study them, the more unsettling they grow. Here beauty offers no reassurance. It delivers precision. Every crisp boundary, every finely drawn filament, every subtle warp stands as proof of music, relentless forces operating across inconceivable reaches. The images feel serene only because the universe follows rules with merciless uniformity. Gravity never pauses. Dark matter never relaxes. Music, its hold. Expansion never eases. What appears visually peaceful actually signals a cosmos ceaselessly tugging, warping, and extending. Music, everything within it. Euclid's findings powerfully support one troubling notion. Galaxies do not design cosmic structure. They decorate it. The true architects remain unseen. Dark matter halos coalesce first, collapsing under gravity well before stars flare. Galaxies ignite later, inside halos already formed by something invisible. Euclid's joint mapping of galaxy shapes and lensing effects makes this order impossible to overlook. The visible universe rides atop a concealed scaffold that decides where galaxies may form and how they develop. The chilling implication is that everything observable is secondary, almost trivial, next to the unseen music mass steering the cosmos. One of the most staggering features of Euclid's work is its compression of cosmic time into music single frames. A lone image can hold nearby galaxies as they exist now, distant ones as they appeared billions of years ago, and faint traces from soon after the universe's birth. Past and present share the same photograph. Euclid, therefore, doesn't merely capture space, it captures history. Scientists follow changes in galaxy forms, clustering patterns, and dark matter's growing influence. Music, simply by comparing objects at varying distances. The unsettling truth dawns that our present forms just music, a narrow layer within a far grander cosmic sequence, one underway long before Earth formed and destined to outlast it. As Euclid advances through its 6-year survey, many researchers now suspect its greatest finds may lie outside its original goals. Designed to probe dark matter and dark energy, its unmatched resolution and breadth are already exposing oddities, unexpected music alignments, and faint patterns that resist current models. Past experience teaches that instruments opening such wide views bring surprises. Euclid could compel revisions not only in cosmology, but in core physics. The genuinely disturbing prospect is that the universe Euclid unveils might not fit fully within our present explanatory toolkit. One of Euclid's most disquieting powers is displaying the universe at two vastly different scales at once. Music, a single observation seizes huge cosmic frameworks spanning millions of light years, while simultaneously resolving intricate details within individual galaxies and star clusters. That dual perspective reveals something profoundly uncomfortable. The same unseen forces sculpting the music's grandest filaments of the cosmic web also guide star formation inside modest, irregular galaxies. Euclid proves the universe isn't neatly tiered from large to small. Everything links. Large-scale gravity shapes local events, so phenomena across unimaginable distances can subtly steer processes inside one galaxy. The cosmos is not modular. It is interconnected at every level. Plenty of areas Euclid imaged, Perseus, the Horsehead Nebula, nearby globular clusters, were already familiar to astronomers. Yet Euclid exposed features there that no one music had previously detected. Fresh dwarf galaxies, concealed star clusters, faint stellar music, populations buried in earlier observations. This prompts a troubling question. If our knowledge proved so partial, even about well-studied regions, how much remains undiscovered in places we've scarcely glimpsed? Euclid quietly shows that music, assumed familiarity, can foster misplaced confidence. The universe we believed we knew still conceals layers we never reached, simply for lack of the proper vantage. Euclid's view of galaxies as far as 10 billion light-years distant effectively turns the telescope into a time machine. Greater distance equals younger universe. Blending visible and infrared imaging, Euclid places music galaxies accurately in three-dimensional space and time, enabling reconstruction of how cosmic structure expanded from near-uniform beginnings into music, today's intricate web. The disquieting insight is the speed of that growth. Dark matter aggregated early. Galaxies assembled swiftly. The universe structured itself with a decisiveness that challenges music, gradual formation theories. Euclid suggests cosmic evolution may have unfolded more forcefully. Music, more rapidly than long assumed. As analysis of Euclid's initial data, music presses forward a familiar yet unwelcome pattern surfaces for astronomers. Questions multiply faster than answers. Each newly charted structure brings anomalies. Each fresh lensing detection stirs doubts. Music about gravity's nature. Each tighter expansion measurement edges dark energy models toward uncertainty. Euclid isn't merely closing knowledge gaps. It's revealing how tentative that knowledge truly is. The real fear isn't our current lack of answers. It's that the universe Euclid displays may demand entirely new questions we haven't yet learned to formulate. Step back and consider all Euclid has shown. Music, thus far, and one reality stands undeniable. These images unsettle not because they depict horrors, cataclysms, or cosmic threats. Music, they unsettle because they reveal order, an exquisitely structured, tightly interwoven universe ruled by forces we cannot see, touch, or fully explain. Dark matter isn't peripheral. It is the primary builder. Dark energy isn't background speculation. It actively tears the universe apart. And gravity, music, as currently understood, may tell only part of the story. Euclid compels us to face an awkward fact. Most of the universe stays invisible, and most of what drives it lies beyond direct perception. Galaxies trace paths not of their choosing. Structures rise where unseen mass permits. Even voids bear shape, tension, and form from forces predating stars. What seems music, remote, and theoretical suddenly feels close because the same cosmic machinery fashioned our galaxy, our solar system, and ultimately ourselves. Reflect on that. We do not stand on firm ground inside a placid universe. We travel within an immense, restless framework erected on unknown physics, traversing space by rules we're only starting to perceive. Euclid's images are beautiful, yes, but they are unflinchingly honest. They present a universe that does not center on the visible, the easily measurable, or the comforting. And this represents merely the opening chapter. Euclid has finished only a small portion of its work. 99% of its music map awaits completion. If these early glimpses already strain our models of dark matter, dark energy, gravity, and music, cosmic development, consider what the complete view might compel us to reconsider. If you wish to keep pace with these revelations, if you prefer to grasp their deeper meaning rather than simply admire the views, stay subscribed. Drop your thoughts in the comments. This marks one of those rare points where science silently rewrites music, the fundamentals. And never forget, the universe Euclid is exposing isn't novel. It has always existed. We're only now seeing it for what it truly is. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.